From the aqueducts of the Roman Empire, through water mills in the Renaissance, to the modern-day Hoover Dam, the abundance of flowing water as a renewable source of kinetic energy has always been unparalleled on our planet. The problem is finding an environmentally friendly and economically viable way of harnessing this power without the construction of a dam or other major infrastructure, as these tend to cost millions of dollars, take multiple years to complete, and cannot be installed in remote areas where populations could greatly benefit from predictable, renewable electricity. Probably the biggest appeal of renewable energy is that it harnesses naturally occurring energy and doesn't burn fuel to generate power. Unlike fossil fuels, with prices that can vary greatly from one year to the next, renewable energy devices use the sun, the wind, and the water to generate electricity at a consistent price. Unfortunately, the wind doesn't always blow and the sun doesn't always shine, making wind and solar projects less predictable and reliable when compared with conventional fossil fuels. There can also be significant upfront costs associated with large wind and solar farms, putting a quick return on investment out of reach. Rivers, on the other hand, flow every day of the year, meaning that electricity can be generated every hour of every day. Flow rates do vary from day to day, but there's a great deal of predictability, especially where seasonal records have been kept for many decades. Humans have relied on fossil fuels like coal and oil to power our rapid technological advancement in the last century. Over the past several decades, however, we've started to see the side effects of using these fossil fuels in the form of pollution and global climate change. As the continued use of these fuels represents a growing danger to the health of our planet and our own individual well-being, many are looking to renewable energy to power humanity in the decades to come. Hydropower has been the dominant form of renewable energy in the United States and in many other developed nations for well over a century now. According to the Department of Energy's statistical body, the Energy Information Administration, hydropower accounted for 7% of the electricity generated in the United States in 2009, representing 66% of renewable power generation that year. In the early 1900s, up to 40% of the electricity generated in the United States came from hydropower. Recently, though, hydroelectric dams have fallen out of favor due to their high cost to build and their negative impacts on river ecology. This is where microhydropower comes in. Microhydro, which includes run-of-the-river products, is technology that uses the currents of rivers with smaller devices that are deployed in-stream and usually do not require major infrastructure construction or altering the environment to generate electricity from flowing water. Although these decentralized power generators don't produce as much electricity, they cost far less and have a much smaller footprint when compared to a conventional dam. The majority of the world's population lives by the oceans and rivers. In 2010, 80% of the population lived within 62 miles of the coast. A few spins around Google Earth show how many major urban areas, both modern and ancient, have sprung up around rivers. We've known for a long time that being close to a river means having access to fresh water, a navigation channel, and energy. With microhydro, electricity can be generated closer to where it's needed, meaning it can be more efficient and cost-effective. The Vertera turbine is a vertical axis turbine that uniquely harnesses the power of flowing water. It can be manufactured as a single shape that is approximately 8 feet in diameter and 3 feet tall. When installed, it's completely submerged and out of sight. The turbine can be deployed in rivers, oceans, and man-made canals. The Vertera turbine captures the kinetic energy available in flowing water to generate electricity with minimal impact on the environment. The unique design of the turbine allows it to operate efficiently in low-speed flows in shallow water, where conventional horizontal axis turbines cannot. It always rotates in the same direction, regardless of the current direction or in changing flows, as is common along ocean shorelines. Potential customers are homeowners, businesses requiring renewable power, municipalities, power utilities, and communities located near a flowing body of water, including those in remote and underdeveloped regions. The Vertera turbine is designed to transform the way our customers generate electricity and enhance their quality of life. Compared with conventional fossil fuels and other renewable energy sources, the Vertera turbine system has significant advantages. First, because of its vertical axis, the diameter of the turbine is not limited by the depth of the water. It can be installed in relatively shallow depths and low flows, meaning it can generate power where other designs can't. With only one external moving part, it has no pinch points, which is one of the causes of fish fatalities. Experts in the Minnesota DNR who have examined the turbine have concluded that it poses little to no threat to wildlife. Because it's a single shape, the turbine can be constructed as one piece, which makes it very strong and durable. Given that flowing water is the turbine's input, the price per kilowatt hour is far more predictable and stable when compared to fossil fuels with prices that are subject to the short-term volatility of the global commodities market and the long-term finite nature of fossil fuels. Additionally, because its input is flowing water, the Vertera turbine is a zero-emissions power generator. Lastly, because of the turbine's unique design that is able to harness a great deal of kinetic energy from a smaller footprint, it will offer an exceptional value, not only in the renewable sector, but in the energy industry as a whole. Our main objective over the next 2 years is to prove that the Vertera turbine system is an economically viable and reliable solution to meet the ever-increasing demand for renewable, clean energy across the globe. There is no alternative to intelligent power.